Take your computers out. Get logged in. JoinPD.com, ladies and gentlemen. JoinPD.com. Good morning, ladies and gentlemen. How are we doing today? Wonderful, wonderful, wonderful. No. What unit is the last conversion in? No, it's not. Not when you did 9 atoms over 1 FU. No, it did. You've canceled those out with your last conversion. Look at your last conversion. What is it? What over what? 9 what? Over? So you canceled out FU then. What unit are you in? What unit did the problem want? Then you're done. Then you're done. What? That's fine. Remember, atoms and particles are incredibly small. There are going to be a lot of them in a sample. A lot. A lot. Did you have a pass can on?
No, I don't.
Okay, thank you.
Are we gonna review or
Review what?
like this?
Like this. I don't know what this is.
Yes.
Isaiah.
This is my red one. This is my red one.
Austin.
But I feel like I'm
Alexis.
What
Rosia.
color?
Sophia.
White. What?
Angel. Yes. Yuritsi.
Wait, Mr. Brown, what if
Olivia.
the quiz on?
Paper.
You're not funny. Oh my God, Mr. Brown.
You're really asking me what the quiz is on.
It's empirical formulas.
You're honestly asking me what the quiz is on.
Yeah,
When,
yeah.
as Cynthia pointed out, I never tell you guys. So I decided I would write it on the board for you, and yet you're asking me what the quiz is
Well,
on.
I see determination of empirical formulas.
Okay,
Lab.
so that's what it's going to be on.
Well, that
And
says lab, not quiz, so. That says conversions.
which is what the quiz is on. And what does it say underneath?
I can't read that.
Well, then you need to get closer because there's seats up in the front.
Or you can just like tell me,
I have multiple times. I've told you yesterday your quiz was going to be 2 problems. What were they going to be? Farhan. All right, so 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 17. Excellent. Excellent. All right. Here's your code for the Pear Deck, ladies and gentlemen. GCHAKN. GCHAKN.
So we are reviewing.
Some things.
You just couldn't tell me that. You're so secretive.
I am. That's why I hide things from you. That's why I don't tell you what's on the quiz until the day of the quiz.
Well, I was the
That's
one
why I
that
don't
asked
let
that
you know
question.
those things. Because I am very secretive and I try to hide it. And the best thing as a teacher to do is surprise your students by giving them a quiz on something you haven't prepared them for. But I will be honest with you and tell you this. If you bomb the first quiz and you do not do well on today's quiz, next week, Friday, there's a test.
I won't be there.
Can I take it on Wednesday? Okay, please.
Next week, Friday, there will be a test. And if you haven't done well on the 2 quizzes, your chances of doing well on the test aren't very good unless you have done something between those 2 quizzes and the test to prepare yourself better for the type of questions, because the molar conversions are going to be on the quiz, and so is the determination of empirical formulas. So again, ladies and gentlemen, if you're not getting this, I'm here before school every morning except for Fridays. I'm here after school just about every day except for Fridays. I'll be here, but only till 3:15. And I'm here during home base every day.
What lunch?
I'm going to eat. Look at me. This body needs
What
to eat.
lunch do you have?
It doesn't matter. That is the one period of the day that I get off. So you could come and see me
What
before
period
school.
do you
You
have?
could come and see me after school.
Thanks,
You don't have a
Mr.
class
Brennan.
first hour.
I
You
do
don't.
have a
You have
class first
conceptual.
hour.
What
It's
about
conceptual
second
chemistry.
You don't have any third hour or fourth hour.
Why are
Oh, you have a
so
fourth
behind
hour.
when
You have a
do
fourth hour.
lunch?
You don't have a third hour, do you?
You don't get paid for staying behind.
Do you?
So I don't know why you wouldn't just use your lunchtime
For what?
for helping. Well, okay, never mind.
So can I ask why you can come in at lunch, but you can't come in either before or
no.
after school?
I'm just no.
Cause I
I'm
have
just saying.
practice,
For what?
track,
When? Before school?
after school.
So again, I'm confused as to why I'm here at 6 o'clock in the morning.
I don't think you're
Okay.
like,
Okay, we get it.
7:20.
So
Rich, 10 minutes is not good enough.
I guess 10 minutes is more than no minutes. Write you determine the empirical formula to be the following ratios. Please name this compound. Write a formula and name this compound. Now you know it cannot have a 1.5 in it.
How do I put the little number below?
You hit control and the comma key and then type.
You can't.
You just gotta press space.
Oh,
Like,
It
well, maybe I don't think it lets you.
It might not let you do it in a Pear Deck. I'm sorry. But I'm looking for the name here.
Aluminum chromate.
Oh, the name?
I'm looking for the name here.
Is it aluminum chromate?
Well, what about the, oh, let me see this, man.
Chromate. CRO. Oh, that's foreign.
What?
Does the name stay the same even though the charge is changed?
The name is not changed by the charges.
There's none of these.
It's aluminum chromate. Look at chromate. CRO.
Chromate? Where's chromate? You mean dichromate?
No, chromate on the back of your periodic table.
Oh,
Ions.
all done. Thanks.
You are correct. I'm sorry, you cannot do subscripts with Pear Decks. But if you put the number, if you want to write the formula and you just put the number in there, I'm fine with that. Even if it's not a subscript. Okay? But all I'm asking you to do is give me the name. Okay. Now, the key to answering this question, ladies and gentlemen, is that we know we cannot have a decimal in a ratio. We might get one, but we can't leave it this way. So how do we get rid of this decimal of 0.5? We multiply everything by 2. Everything. Okay? So what that gives us, ladies and gentlemen, is Al2 Cr3 O12. Now, polyatomics in empirical formulas. When you have a polyatomic in an empirical formula, it is almost always going to be written in an unreduced form because unless it happens to be the same charge as the metal it's with, there are probably going to be multiples of that polyatomic. In other words, it's going to be in parentheses with a number after it. So when you get to this point, this is your polyatomic. So we now want to reduce our polyatomic. And if we just reduce the polyatomic, Cr3O12 becomes what when it is reduced? CrO4. So that is the polyatomic we are looking for. Now, how much did we reduce it by? So that 3 then goes outside of the parentheses. Okay? That 3 goes outside of the parentheses. Now we just put the Al2 back in front. So that is the way that it ends up having to be when you have a ternary ionic compound. 3 elements. You're going to have a polyatomic in there. Now, occasionally, that polyatomic may work out to be CrO4 without having to be reduced. If it was with magnesium, sodium, lithium, something with an equal or lesser charge, it may work out that it just gives you the CrO4, but it doesn't always do that. Questions?
So if it was all non-metals or metals,
If it was all nonmetals, we wouldn't be reducing it. We'd probably be talking about a molecular formula like we're going to today. Okay?
and if it's all metals, then
It can't be all metals. I will never, ever, ever, never, ever, never, ever, never, ever, never, ever give you a compound that is all metals. Ever.
Like not a thing, or it is.
No, it is not a thing. Metals do not bond with other metals.
Or you can mix them though.
What do you mean?
Like I can.
Well,
put
yeah, you can
iron
make
in-
an alloy, which is if you mix, say iron and carbon, you make steel out of it. It's an alloy. They're not a chemical compound, but they're just mixed together. And I'm sorry if I cut you off if you were going to say something else. So, questions? So then, here would have been the answer, aluminum chromate, okay? AlCrO4 in parentheses, 3 after it. Questions? Now, I will guarantee you're going to see something like this on the test. It's one of the first 2 questions, where I'm going to give you some ratios like this and ask you to write the formula and name the compound for it. You don't have to calculate them. I will give them to you just like I'm doing here. So this will be the question. Here's the ratio. Ca1, Cl2, O4. You have to tell me what that compound would be.
So do you want the formula? Or do you want
I want the formula. Well, on the test, I'm going to want the formula and the name. Here, I'm just asking you for the name, but I don't know how you can write the name without first getting the formula. So, again, try to come up with a formula. Remember, the polyatomics that are on the back, Cl2O4 is not one of them. You're not going to find that on the back. So you got to figure out what it is.
Wait, can you help
Where's
check
CA?
mine? I'm like.
Where's what?
See,
Ca, element number 20 on the periodic table.
Is that right? Or could it be one of the answers? Oh no, it's only losing one.
Yeah, I was going to say, you're on the right track.
Like that?
Yes.
Oh my god. Wait, we should go.
You're on the right track. Yes. I'm not hearing enough of your conversation to know if you're completely correct. But
Oh, okay, so this one's going to
Yeah.
Oh,
okay. How many
wait, wait, no. CLO.
Don't worry about that.
Yes,
Okay, that was
Okay,
Okay. So don't let the number outside affect what it is. Okay. So I understand what you're saying. You're looking at that there's 4 but it's within that group. What happened to the Does that make more sense? How we doing?
I just do them. I don't want
Okay, there is no such thing as time. Okay. Now,
Is it
first of
CL?
all, what would your formula be?
Can I see the answer?
It's gonna be CaClO2
Alright, so you gotta reduce it.
Write down what you think your formula is for me.
Wait,
I'll leave it like this.
Wait, this.
CaClO2. So
You reduced it. Yeah,
you reduce it.
good, that's the correct formula. Now you just got a name.
Wait, you said C?
Now you just got a name.
ClO2.
Okay, what number was on the other side here?
ClO2.
What did you reduce the CL and the O by?
Yeah, reduce it. So now you just gotta put ClO2.
Alright, so calcium and chlorine, 300.
Exactly.
Give me on.
Alright.
Okay.
I don't know what I just said.
Because this oxygen is right there.
What do you got here?
I don't know. I was looking at this one.
And then we see open how it's because it's
We're getting back to the original.
You're wrong. You're very close, but you're not quite right. I'd love to see the formula that you have for
I
this,
think it's just
because then I could tell you
It's.
where you made your mistake. Okay, so how many CX now? CL what?
Because if you do hypochlorite, then there's not enough chlorine.
Now, look on the back of your periodic table.
Wait,
Cl2O4, what is the closest thing you could find to that?
wait. I was so close. So.
Okay, so this is only got one chlorine, right? Okay, so let's reduce just this part of your formula. Reduce this down to its lowest term. Cl2O4, what would that mean?
wait, it lost
No. I need to write
So
this
what can you
down.
divide this into? The Cl2O4, what number can you divide this into? Okay, so rewrite it, reducing that part of your formula. So that's the polyatomic ion. Reduce that one.
Yeah, you got a lot. Yeah.
Just ignore the Ca for now. Reduce the Cl2O4 down to a lower formula.
So if it's lucid oxygen, it has to have IP.
Yes! Tickets are $25.
You do not need to calculate to take and reduce a 2 out of 4 by a common denominator.
I know, but I so what do you put the ID?
So write it down.
I think
Write it down. What you get? Cl what?
What?
So when you reduce it
That's
to-
crazy.
divide both of
Yeah,
these
yeah.
by.
Yeah.
So
Yes.
take CL divided by 2 divided by 4. Cl2 divided by 2 is what?
We need 40
How many
40
chlorine?
people to get 100.
Write that down.
Because in the
What happens to the O when you
Wait, yeah, why?
reduce it? This is because
in the
No one's gonna want to go to
You're not helping her.
Well, how much will it come?
She's just nervous. Oh.
Well, I know.
Like, you would do it. You're just making her do it.
So now.
But then there's
How
No,
many
it's the same. Yeah,
numbers
it's
do you
that's
use
the
both
CR.
these by?
$45.
So put parentheses around this.
Why is the chocolate?
That's what I knew he wants
Cl2O2.
So they what? Would you guys go to prom?
Just put the calcium in. Now name that.
What? No.
Now name that.
It's been 10 minutes, hurry. Okay.
Nobody is broken down.
So, ladies and gentlemen, again, in this one you have a polyatomic in it. That polyatomic, ladies and gentlemen, comes from the chlorine and the oxygen. They're what is going to give us the polyatomic. So, right now the formula is CaCl2O4. There is no polyatomic that is Cl2O4. So we want to reduce this polyatomic. Again, I'm not doing anything with the calcium. Okay? I am just going to reduce this polyatomic. I can divide both of these by 2. That means it's going to be ClO2. Now, because I can divide both of them by 2, that's the number that I put out there. Okay? That's the number that I put out there. Sophia?
Are you always going to put them in order, or do we have to?
Yes, I will put them in order for you. I will do that for you, yes. So now, ladies and gentlemen, normally the one on the back of the periodic table is ClO what? 3, which is chlorate. What has happened to it here? It lost 1 oxygen. What happens to the name of a polyatomic when you lose 1 oxygen? It becomes chlorite, I-T-E ending. So, ladies and gentlemen, this becomes calcium chlorite. Okay? The ClO2 there, the 2 outside it, calcium chlorite. Questions? There will be nothing like this on today's quiz. Questions? Yes, I just told you this will be the first question or second question on your test.
Oh, I thought you said that quiz. Okay.
No, not on the quiz. I'm trying to get you ready for your test next week.
Wednesday, right? Friday.
I'll tell you what, if you want to come Wednesday after school and take it and be unprepared for it, you are welcome to.
What are we learning on Thursday?
It depends on how far we get. I'm not getting as far as I would like right now. Not our problem, but understand, I do have a few more topics to get through. So hopefully I will get them all done by Wednesday. But I do know this, if you expect to take it during class on Wednesday, there is no way we will have everything done before class on Wednesday to where you can do it. Because we what?
We should take it Thursday during class.
No, because then what do we do on Friday? Do we start something new the day before spring break?
Everybody else can have a fun day.
No, that would ruin my reputation giving you a fun day.
Okay, so when,
Oh my
when
gosh.
Is like us,
Let's get through and we'll talk about this on Monday.
No. You stress me
Well,
out.
we're not gonna be here on Monday.
Why aren't you going to be here on Monday?
Next week Monday well, no, next week Monday. Never mind. I'm
gonna be
let's
here.
go on Tuesday, you guys.
Okay, so let's talk about molecular formulas, ladies and gentlemen. Molecular formula is the next step of an empirical formula. Okay? So in a molecular formula, molecular formulas are formulas for covalently bonded compounds, molecules, sugar, any organic compound is a molecular compound. Anything that does not have a metal in it is a molecular compound. Now, the difference between a molecular and an empirical is some molecular formulas can be reduced. Some cannot. Okay? So, for example, this is a molecular formula. Could you reduce that? No. This, ladies and gentlemen, is something you are all a producer of. Any idea? What is it?
Monoxide. Nope. Okay.
Methane. So every time you fart, you create methane. And don't give me that surprised look like you've never farted, Alexis.
I'm a girl. I don't fart.
Whatever. C2H6 is ethane, another organic compound. But C2H6 can be reduced to what? So you remember the other day where we found the formula of CH3? That was the empirical formula of ethane. It is the reduced form of it. All we can ever find in an empirical formula is the formula in lowest terms. That may or may not actually represent the molecular formula, which is what these two things are, here and here. So sometimes the molecular is also an empirical. Sometimes it is not. Okay? So, the difference between this formula and this formula is that this one has been reduced by 2, correct?
Wait, Wait, but how did the CH4 go into 2?
What? This didn't.
How did that become?
Sorry, I'm trying not to confuse you. This is a different compound than this. I was saying that these two are both molecular formulas. Okay?
So how do you know when, like, because you know how for empirical formulas, how if it was C2H6, we would do CH3 with the parentheses outside of it too?
Okay, we're going to kind of do the opposite. Hold on.
How do we know when to do the...
First of all, the problem has to tell you the molecular formula mass. It has to tell it to you. So those problems that we've kind of been skipping, that we said you could do the empirical part but not the molecular, it has to give you a molecular formula mass. Now, this has 1 carbon and 3 hydrogens in it, correct? Carbon 12.01, hydrogen 1.01, so that's 3.03. So that means this has a mass of 15.04, correct? Grams per mole, right? We can agree on that? Anyone questioning where I got that from? We're clear on that, right? Okay, well, let's take a look at the mass of this. This has 2 carbons and 6 hydrogens. This is 24.02 plus 6.06. That is 30.08 grams per mole. What do you notice about these two masses? This is half of that one. Or there is a difference of times 2. This is 2 times bigger, right? What did we reduce these numbers by?
2.
Whatever the difference in mass is, that's how many times you had to reduce your formula. That's how many times you had to reduce your formula. That is why they are giving you that one extra piece of information. They have to give you the molecular formula mass so we can figure out how many times we reduce the formula. But the ratio of the masses of the formulas comes out to be a whole number. 2, 3, 4, 5. So let's take a look at an example.
And then are those like the answers for like for the empirical formula? You know how to get like whole numbers? Are those our whole numbers before molecular formulas? Does that make sense?
Well, empirical is still going to be a whole number.
That's why. So then, like, it's kind of like the same thing.
But the molecular is going to be larger numbers that could be reduced.
Okay.
Molecular formulas, so C2H6 can be reduced down to CH3.
So when they reduce, they're molecular. When they're not reduced, they're
Correct. But a molecular could also still be in lowest form. CH4. You can't reduce that. It's a molecular formula, but you can't reduce it. Go. Sure. Go ahead.
Okay. Scram, stop talking.
I obviously
No, I know
didn't
you're
do a good job because I didn't hit her.
What the heck?
Just leave it there.
All right. There it is. So, the way to find the molecular mass factor, how many times we reduced it, is we're going to take the molecular formula mass, which you have to be given, divided by the empirical formula mass, which after you find the empirical formula, you find the mass of the compound that you created, CH3. Okay? When you divide these two, you will come up with a whole number. You will come up with a whole number. And it will not be none of this 0.5, 0.33, 0.25. It will always be a whole number. Now, maybe it'll be 5.99, which we round to. Maybe it'll be 7.001, which we round to 7. But it has to be a whole number. Has to. Go.
So after we do our empirical formula and we get our new what is
Formula.
it? Formula, we find the mass.
Mass of it, yes.
like by looking for the mass and adding them up?
Correct. Formula mass is always found by taking any formula and adding up the masses of everything involved. Always. Let me show you, because it's easier for us to see this than for us to keep talking back and forth. A chemical compound is found to contain 49.98 grams of carbon, 10.47 grams of hydrogen. Determine the compound's empirical formula. That is what we always begin with. That is what you are going to do in your quiz today, but you're going to stop there. Okay? Then, given the molecular mass of 58.12, find the molecular formula of the compound. We're using this at the end, not at the start, at the end. Okay? So, we are going to take it, we're going to take our grams of carbon, we're going to convert it into moles using formula mass for this formula, carbon, right? We get the moles. We're going to take the grams of hydrogen, we're going to use 1 mole over the formula mass, 1.01. We are going to get the moles of hydrogen. You are going to be doing this in minutes. Okay? When we get to here, what do we do with these two numbers? We divide them by 4.16. So, here we can still get a half. Okay? We can still get a half here because we're finding an empirical formula. 1 to 2.5, what do we do to these numbers? We multiply by 2. So we end up with an empirical formula of C2H5, correct? Now, find the formula mass of that empirical formula. 2 times 12.01 plus 5 times 1.01. That gives us 29.07. That is the empirical formula mass, the mass of this formula. Now, to find the molecular formula, we take the given mass in our problem divided by what we calculated here. What factor does that come out to be? 58 divided by 29. Oh my gosh, please don't go to a calculator. 2!
Wait, so what units is it in grams?
No, that's
That's
the
two.
multiplier. That's what we're going to multiply that formula by. So instead of C2H5, our final formula is actually 10. C4H10. We reduce the formula to get to C2H5. We find what we need to multiply it by, and we multiply our formula back up to the molecular formula.
So is there ever going to be a time where we're going to have to do the opposite of it?
What do you mean the opposite of it?
Like, instead of, multiplying them by 2, we're going to have to, it's going to be, we're going to have to reduce it. I don't know.
No.
You do that every day.
Because here's the thing. By finding the empirical formula here, you are finding it in its lowest terms. Okay? Now, it is possible that after you find this formula, this mass and the mass that you were given could be the same. Which would mean you didn't what?
Do it right.
No.
We didn't multiply.
What is 29.07 divided by 29.07?
That's the lowest.
1. It means that the original formula that you were given is the molecular and the empirical. It is both. And it can do that.
Figure that out without doing all the work.
No.
Just look at the molecular mass.
Sure. Do you know what all the molecular formulas in the world are?
Yep.
Okay, then just pick out whichever one it is, write it down, and then you should know. So, for example, I know this formula can't exist, C2H5.
Why?
Why? Because your carbon wouldn't be completely stable because there's not enough hydrogens to fill up both carbons here. Each carbon can form 4 bonds. So if this was C2H6, then the carbons would be full. That would be a molecular and an empirical formula. But it's not. And I can tell that because I know about how many bonds carbon is supposed to make. I don't think you guys have learned that yet. And you're not going to from me until you take organic chemistry in college. Okay, so now let's check out another one. A colorless liquid composed of 46.68% nitrogen and 53.32% oxygen has a molar mass of 60.01. What is the molecular formula? What? Yeah, go to the bathroom. Go ahead. I'm just teaching you important stuff, but go, please. My God, you people have major bathroom issues. Major. God, I wish I was like
Some
you.
people just stay hydrated.
I understand it. You know what? Teachers don't get to go use the bathroom during class.
Well, maybe
Yeah,
I
you do.
shouldn't have been a teacher.
You're right. I shouldn't have been. I could make a lot more money as a chemist in a chem lab. I might be happier. Probably wouldn't enjoy June, July, and August as much, but oh well. Life goes on. Let's move ahead. So we're going to take and we're going to convert our percentages into grams by assuming
They are whatever. They're numbers of
100 grams.
You would just
Thank you. Assume a 100 gram sample. So that makes our percentages into grams. We then use the formula mass of nitrogen to get to the moles of nitrogen. Use the formula mass of oxygen to get to the moles of oxygen. Look, what is our formula going to be?
1.
Wait, what are you talking about?
It's gonna
One
be
is not a formula.
C, or it's gonna be N-O. No.
Yeah. We're going to divide by 0.33. I was hoping by now you could kind of look at these numbers,
Which is 1.
which are both 1,
Exactly,
which
that's what
means
it
your
said.
formula is going to be
Exactly.
That's
NO.
That's what we both said.
Right, you said 1. Yes, my bad because I wasn't able to interpret that into NO, meaning one of each, meaning, yes, we understand that, Mr. Brand. Anyway, moving on. Here's our formula. Empirical formula is found by taking nitrogen, 14.01. One of them, plus oxygen, one of them at 16.00. That gives us 30.01, right? Look at the mass up here. 60 divided by 30. Someone?
2.
2.
But it's not gonna be
Reduced it by 2.
We reduced it by 2, so what's the formula?
N2O2.
N2O2. That was
But
what
that's
we...
not like, oh, a pot. Okay, never mind.
Now, this is a molecular formula. How do we know? It's not reduced. It's 2 nonmetals. Okay?
And then the empirical formula is reduced.
The empirical is always reduced, yes. All ionic compounds automatically come out in empirical formulas. Automatically because we reduce them. Questions? No, I've just been doing this for a long time.
Don't you
Okay.
get like tired of just learning the same thing over and over and over and over? Like, don't you want to learn?
If you
something
haven't noticed, I do change clothes each day.
new? No, but I'm not talking about what you wear. I'm talking about like what you teach. Don't you want to like learn something new and teach something new?
No, I did physics a few years ago. I didn't enjoy it.
What else do you do besides chemistry?
Physical science.
Can you
And believe it or not,
can you-
I almost shudder to say this to you, but you're better than freshmen.
Oh, and then K.
Questions?
Can you teach something else next year so I can take a class?
No,
Do AP biology or something.
I can't teach biology
Why?
because I'm not certified.
Why can't you teach
Do AP chemistry. Yeah.
There weren't enough people who signed up for it.
With everybody.
Everybody
Sign
signed up for it. We just.
Everyone did not sign up for it. There were only under 10 kids
So
signed up
you
for
don't
it.
want to teach 10 kids.
They won't let the class run.
They did for chemistry. It was literally what, 11 of us, 12 of us?
When?
Not chemistry, calculus.
Okay,
Oh
It's
yeah.
not.
for
they
calc.
all right.
Only like 11 of us.
It depends on how they have to make cuts somewhere. They kept the AP physics class because there were more kids signed up for it. They cut the AP chemistry and AP bio. Sorry.
Okay, well, everybody's going to sign up for it next year, so we're going to make you teach us AP.
Second of all, I technically don't have to teach it. I've never taught AP
Who else
chemistry.
is going to teach it?
We'll find somebody. We will hire somebody.
No, you're the science leader, whatever.
Yes, you're right. I am. And I'm going to lead myself right off of cliffs. Put everything away, ladies and gentlemen, except for your periodic tables, a calculator, and something to write with.
Is there space in there to write, or can I use this? That's not enough.
And the whole backside.
Still not enough.
Hey, put your computers away.
Mr. Brandy, you want to write my college letter of recommendation?
Yeah, you should write all of us.
You said we're your favorite class.
You're like our favorite teacher.
Please don't write mine.
Please pick a class that you, one, do well in, and two, the teacher likes you.
I do well in my class and you like me.
I do well in here. You like me.
He doesn't like anyone.
100%.
Correct.
100%.
Have you heard me talk about my wife and children ever?
Yeah.
Oh, yeah. Only bad.
Proof. He doesn't like anyone.
He loves them deep down. He does. And he loves us too. Deep
Because
down.
I was foolish enough to ask a question.
But you're so mean though. Like, why would you say yes?
You would have to ask her. I still wonder that to this day. Okay?
Hey.
What?
Didn't you propose to her with a teddy bear?
Yeah, and if that's all it took for her to say yes, that's pretty weak on her part.
You're not
Okay.
down.
A ring.
Being
that's-
given a
Yeah,
teddy
yeah.
bear? Oh, yes, yes, yes.
Wait, does she still have the teddy bear?
I have no idea. You'd have to ask her.
What's her
Yeah.
email?
Did you give her a ring? Did you give her a ring eventually?
The ring was with the teddy bear.
Thank you. Thank you.
Come on, guys. Come on, guys. We've been through this.
It was like a bear holding.
Oh. Well, that's different. You only said a teddy bear. I thought he only gave her a teddy bear, and I was like, wow, that is really
Okay,
big.
but they got married back in like.
Back in 1990.
But I was still like,
It was a
so
ring
was like,
They got married during the
obviously
World
they're
War II.
gonna do the whole marry me thing.
It was after World War II, but before Vietnam.
Oh, okay.
So like
A
1882.
long time ago.
Mr. Ben, when's your birthday?
What?
He doesn't
When?
have a birthday.
I don't have a birthday. I was hatched. I wasn't born.
Your hat.
When I was
What
reading,
was your hat day?
Is that why you're immortal?
What was your hat day then? What day was
My hatch day is at a time of the year when none of you are around.
so July.
Nope.
No one
December.
exists in July
It's
except
June.
for
January.
He was born before humans.
Well, you said that he graduated in 88.
I was born before calendars, so they
88.
didn't have a month. They didn't have
Like
a
that's
day. They didn't have a year.
You graduated high school in '88.
Yes. Or they threw me out of high school in '88. One or the
Give
other.
us a zero. The year 88.
You're
Not
so
like
exactly
74.
54.
I know. Because you're 4 years older than my mom.
Stop.
You're 54. Right? 55.
Well, that's pretty good math.
So old.
Okay, go to work, ladies and gentlemen. If you have questions, let me know. Show all your work. Now, the problem where it's an empirical formula, you have nothing to worry about with sig figs. There are no sig figs in an empirical formula. The problem where it asks you to give me atoms or give me something like that, please remember, if it's atoms, can you have part of an atom?
No.
No, but it's probably a very large number in scientific notation, in which case you would have to account for sig figs and tell me how many sig figs.
Oh.
Wait, no, it's not now.